Everything on this video and on this page deals with isometries. You're not going to see any dilations on this one. When we did dilations the other day, what was the key operation? What did I tell you to think about? Doing a dilation, what happens? Addition, subtraction, multiplication. We multiplied by things less than 1, that created a reduction. We multiplied by things bigger than 1, that created an enlargement. Everything on this sheet is just isometries. So we have same size, flips, turns, and slides, reflections, rotations, translations. You can know all the geometry in the world, but if you don't remember that your quadrants are 1, 2, 3, and 4, then you're not going to get this right. Make sure you know your quadrants. Trapezoid is located in quadrant 2. I'm up here. If I'm flipping or reflecting across the x-axis, where do I end up? Do that. Put a dot. Put some dotted lines. Put another dot. We'll call this A. We'll call this A with a tick mark. What did we say the tick mark represents? Prime. If you are reflecting the same distance on the other side of the line. So let's put some slash marks on those two distances. This distance from here to the x-axis, and then another slash mark set on that distance. It's got to be the same distance away from the reflecting line. That was choice H. Quadrant 3. We're going to take a look at just reflections on one of our 8 remaining days. So when you come in and it says transformations, it might say reflections only. Okay. So we'll focus on different types of reflections that you might see. You probably know what line symmetry is, but maybe you don't know what point symmetry is. Line symmetry, think folding. So which of these letters can we fold perfectly so that they overlap on each other? D. Where can I fold D?
And like that, yeah.
Like that? Can I fold M?
Yeah.
Can I fold H?
Yes.
Yes.
Both great.
But can I do it at least once?
Yeah.
Can I do S? No, even if I do it diagonally or halfway, when I fold it, it's not going to coincide on both sides. The top half, if I do S this way, the top half is not going to coincide with the bottom half when I fold it. So line symmetry, so far I've got those 3. I've ruled out S. Point symmetry, I want you to think, does object look the same upside down? If I turn something completely upside down, does it look the same? Does D look exactly the same? No, it's the straight side is going to be on the right. M is going to look like a W. Now, does the object look the same upside down is not a good mathematical way of looking at it. It's a good way to remember it. The actual definition, pre-image and image look identical after 180-degree rotation. That's the actual technical definition of point symmetry. It's a very specific type of rotation. It's 180 degrees. It just so happens that when you do 180 degrees, you're basically turning the object upside down. It doesn't matter where the points fall. What you want to think about is, does it look pretty much identical afterwards? What am I looking at for number 3?
Reflection.
Reflection. Be careful. If you think something's easy, it either is easy or you're missing something. Is A and A prime the same distance away from the axis?
Yes.
Yes. Is B and B prime the same distance away from the axis?
Yes.
We're probably looking at a reflection. Did everybody pick A? Number 4, which is line Q. We're looking for the best folding line, best reflecting line. Since that's not equilateral, we can't use those other ones. This is only an isosceles triangle, so we just have this one line of symmetry through the middle, which is actually the y-axis. Raise your hand, tell me what you got for number 5. Chase?
I got you.
You got U. Let's take a look. Where are we starting? Point Q. Which way are we going? We're going clockwise, which means we're going in this direction.
Because 180 is T.
Say that again?
180 is T.
All right, so we know from here to here is 180 degrees. So can we rule out T since we're looking for a 240? We can rule that out. S doesn't even go that far, it only goes to here, so that can't be right. And V, how do we know it's not V? Did you put any specific numbers in the drawing? How many degrees in the circle? 360. 360. So if I'm seeing a hexagon inscribed in a circle, say that again? Did you put 60?
Yeah.
Now I can see that I need just an additional 60 degrees. We went from here all the way to here. That's choice U. Next page. Raise your hand, tell me what you think number 6 looks like. Farhan. J, 180 rotation. Let's take a look. If it's a 180 degree rotation, then I should be able to put a handle on a portion of this. If I turn it with the handle, then that handle, it looks like it's on the bottom of the T. The new handle will be now at the bottom of that T. How many degrees have I gone through to get from there to there? 180. It's not a reflection because if I tried to reflect through that line and flip it over into this quadrant, the T would actually look like this. It would flip from here over to here, not down in that area. Lines of symmetry. Lines of symmetry are that 1, 2, 3, 4, 5. Looks like it's 10, so that would be hopefully the middle. Which equation describes one of those lines? Well, the one that goes through the y goes through at y equal to 5. The one that goes through the x-axis is at x equal to -2. Is one of those there?
H.
Did you guys choose that?
Yes. Yeah.
Before we move on from that one, come back to that one for a second. Typically, the examples that you see are vertical ones and horizontal ones. What if you ended up having a line of symmetry that was like this? What if you had that line that goes through 1, 1, 2, 2, and 3, 3? That doesn't have a name like this. What is the name of that line? What's its y-intercept?
0.
0. What's its slope? If it's going through 1, 1, 2, 2, 3, 3. 1. It's a y equals mx plus b. We're just not showing the m, and we're just not showing the b, correct? So if you ever see y equals x showing up, or y equals -x, think of the diagonal lines that are going right through your origin. You're expected to know your algebra going into this geometry SOA. We'll talk a little bit more about those at another date, whenever we're doing transformation at the beginning of class. Question? J. Oh, yeah, J is one of our choices, but we're not looking at any lines of symmetry that are diagonal. So not for this one. Likely coordinates if we're reflecting across y-axis. You want to focus on points and not the entire object. This happens to be a pretty simple object, so there's only 2 points, but still focus on the points. For a reflection, you want things to be at a 90-degree angle. Write down reflection, write down 90 degrees, and same distance from reflecting line. What do I mean by that? I mean that if I look at R, I'm going to come back to the reflecting line and make sure that I make a right angle to it. How many blocks away is it? 4 units. I need to go 4 units on this side to find the other point. I need to maintain that right angle with the x-axis, the y-axis. What am I going to call this?
R prime.
R prime with a little tick mark. Do the same for S. S is 1 away. S prime. My new shape is from there to there. We're going to do a lot of this the day that we do reflections at the beginning of class. That will probably be in 3 or 4 classes from now. Most likely coordinates of R prime. What is that? Is that 4, 3?
Yes, I
Translate. What's another word for translate? We're going to slide. So the orientation is going to be the same. A and D will still be on the bottom. B and C will still be on the top. New point. D, -1, 2. What do you want to call the new D? D prime. Everything else gets translated in the same manner. So how do I get from D to D prime? Down 1, 1, 2, 3, 4, 5. Do that with all the rest. Down 1, 1, 2, 3, 4, 5. Down 1, 1, 2, 3, 1, 2, 3, 4, 5. A, 1, 2, 3, 1, 2, 3. So my new figure would be there. What am I trying to find? Point B, that's this one over here. -3, +4. Everybody choose G.
Oh, yeah.
Yeah.
That's B prime, that's A prime, that's C prime. I want to add something to this problem. We learned that we can symbolize translations with addition and subtraction. What would my formula be for moving from here over to here? How much does it move down?
X minus 1. Y minus 1.
Y minus 1. And how much movement left to right? It's moving left, 1, 2, 3, 4, 5. So we get 2 subtractions here. Next page. We have another reflection, it looks like, but make sure. If it's a reflection, then those should correspond, and they do. C, C prime, B, B prime. So that matches up, because there's only one reflection on here. Some of these problems have been taken off of older SOLs that were a little bit easier. But some of these problems come up every single year, no matter what. You'll see lines of symmetry problems. You'll see basic reflection, rotation, and translation problems where you're just expected to know your vocabulary, and the state wants to know if you can recognize which is which. Symmetry problem. I'm looking at line L only. Can't use them because I've got these figures here and they don't appear on that side. Be careful. A ends up here, B ends up here, C ends up here. What's happening? Are we reflecting or sliding?
Sliding.
It's a slide. What's our only choice on here that's a slide? F, translation. More symmetry problems. Next page. 14. This is a rotation. We're being told it's a rotation. Which of the following indicates the correspondence of the vertices? If you have trouble visualizing these things, put in there. If I rotate this, what's that happy face going to look like now? So, if I connect a handle to it, and I'm moving this thing so that now it's pointing down, what corresponds to A? What corresponds to C? If you can't see that, some people have trouble visualizing things like that. Think about how far it is from the centered points. C is the farthest away. X is the farthest away. They correspond. B and Z are closest, so they must correspond. Which choice shows that correspondence?
G.
Choice G. And last one.
That's a lot.
Reflection across the y-axis. If the reflecting line goes through the object, then you're going to have overlap. And what that means is that the stuff on the left jumps to the right. So X is going to jump over to here. The Z is going to jump over to that side. But the Y is already on the right, it's going to jump to the opposite side. It always jump to the opposite side of your reflecting line. Now just focus on the three new points. Here, here, here. You'll see overlap with the original figure because the line is going through the original figure. What am I doing? What is the coordinates of Y prime? Y jumped over to here. That's -3, +2. Keep that with your other two pages. What other two things do you have right now that have transformations on it? You have a transformations homework sheet that had 8 problems on it. Then you have dilations, which had how many?
4.
Just 4. Every day you're going to get something on transformations. Keep it in that same section. Surface area and volume. You're not doing all of this sheet. Don't do anything until I give you directions on it. And where are all the surface area and volume formulas? You should probably take that out. If you don't have one, there's about 200 of them up there.
200. That's a lot. Yeah, never. Actually, but again, we have to skip the soccer practice instead.
On the SOL, the surface area and volume section is the section that people have the worst results on.
I'll get 100.
Because they think, they get complacent, they think because it's on the formula sheet, they don't have to learn.
Oh,
And then they start looking at the variables involved and they realize, I don't know what the variables are. I don't know which numbers go in there, so they can't do the substitution. So make sure when we're doing surface area and volume,